In this problem, we have a 1.4 kilogram block. It slides freely across a rough surface such that the block slows down with the acceleration of negative 1.25 meters per second squared. What is the coefficient of kinetic friction between the block and the surface? So, analyzing the problem, we know that we have a block. The block is initially looks like it's sliding across the floor, so we'll draw a velocity arrow. So it looks like it's sliding with a velocity to, let's say, to the right. We know that it's slowing down with an acceleration of negative 1.25 meters per second. So I'm going to just label this V just to let you know its velocity, but it's slowing down. So we know that there's an acceleration in the opposite direction, all right, of negative 1.25. So because the velocity is pointing to the right, the acceleration is pointing to the left, they're going opposite directions here. That means the velocity is going to decrease and eventually the block will reach a complete stop then. But looking at our givens here, we're given a 1.4 kilogram block. Because of the unit kilogram, I know I'm dealing with mass. So I'm given the mass to be 1.4 kilograms. It slides freely across a rough surface, meaning there's no external forces on the block except for the ground. That the block slows down, alright, so it's slowing down with the acceleration of negative 1.25 meters per second squared. Because of the units meters per second square, I know that I'm given acceleration, and it says so right here, and my acceleration is negative 1.25 meters per second squared. What is the coefficient of kinetic friction between the block and the surface? So my unknown is mu of k then. So based on the unknown, we need to find the coefficient of kinetic friction, and the equation to use is the force of friction formula because it contains the variable that we need. And the problem we come up with is this normal force and the force of friction. How do we get rid of those? Well, the equation that we're going to be using is the net force then. And to help explain that, I'm going to draw my free body diagram right here. And I'm going to draw all the forces that act upon the block. So let's start with the vertical components. We know that on the block, we know we have weight acting in the downward direction is being acted upon by gravity. And we also have an upward force from the floor, and that's going to be a normal force then. Now, the block is traveling to the right. However, there's another force that's causing it to slow down, and that force is the force of friction then. So my force of friction will point to the left. Now remember, the net force is when you add all the forces in one direction. So in this case, let's add the net force in the x direction, right? In the x direction, there's only one force. There's just the force of friction. There's no force pushing it forward. So the net force is equal then to the force of friction. So it looks like I can make the force of friction and the net force equal to one another. So that way I can get rid of this force of friction and substitute with the net force. So continuing on, I'm going to set my force of friction equal to the net force. But my net force is equal to mass times acceleration, and force of friction is equal to mu k times the normal force. So I'm going to substitute those in, and looks like I have the mu of k that I need. I have a mass, I have the acceleration. I just need to focus on getting rid of the normal force. So to get rid of the normal force, or to figure out what to do with it, I'm going to go back to my free body diagram, and I'm going to analyze the two forces that are acting in the vertical direction, or the y direction. Notice that the net force in the y direction, it requires me to add up all the forces in the y direction, right? So it looks like I'm going to add the normal force, and because the weight is acting in a downward direction, I'm going to subtract the weight. Now the net force in the y direction, because the block is not accelerating upward, it's not accelerating downward, the net force is equal to 0. Doing some algebra, we see that the net force is going to equal then to the weight. Now I know what to substitute to the normal force. I'm going to substitute my weight. And the weight is equal to mass times g. From here, I can see that the two masses will cancel out, so I could get rid of the mass out of the equation, and I'll be left with mu of k times g equals a. Now, to get mu of k by itself, I'm going to divide both sides by g. These g's cancel, and I'm left with mu of k is equal to a over g then. So now I'm going to substitute my values into the equation. I know my acceleration of the block is negative 1.25. I know the value of g, which is negative 9.8. So I have to just divide negative 1.25 divided by negative 9.8. I get 0.12755,102. Remember, I like to round to 3 decimal places. So for my answer, I'm going to put 0.128. Now to evaluate my answer, so it looks like I calculate mu of k to be 0.128. First, check the sign. It should be a positive number. It should never be negative. So it looks like I got a positive number. That's good. Check if it's too small, too big. In this case, usually the coefficient values are really small, between maybe 0.1 and 0.5. And in this case, it does fall under that range. So it does seem like my answer checks out then.